Hello, my name is Yassine Elkhourassani. I'm a verification specialist in SD microelectronics. I'm working in front-end verification DFC team led by Beatrice Brochier. So I will present the verification challenges, the most recent one that we have experienced recently. So let's start with the first one. Communication challenge has accompanied actually the growing complexity of system on chip. So we have seen a lot of new capabilities and new technologies in system on chip. In that, we have seen capabilities of networking for wiring reduction in SoC, cache coherency, handling global asynchronous, local asynchronous architecture, and so on. So interconnects, which are the backbone of in system on chip, should follow and should keep up with this trend and with this progress. So we are always in front of, we are always facing the challenge of the communication in the system on chip. How can we build the most fluent and accurate test bench in an SoC? Verification of interconnects could be structured in many levels. The first one is the verification of the IP, the interconnect as an IP, to be sure that the basic functionality are correct. So we have to be sure that the IP, the interconnect, is able to make correct data transfers from master to slaves. We should be sure that protocols are coherency is assumed, is expected. And then we have to be sure that transaction transfer is not changing the shape of the transaction. So this is the basic functionality of the interconnect as an IP that should be verified as the first level of interconnect verification. The second level is interconnect integrated in SoC. We should preserve the memory mapping of the IP and to be sure that all masters are talking correctly with all dedicated slaves. So this is the second level. And the third one, which is one of the most important, is the performance verification. We should have one test bench that generates patterns and traffic to be sure to extract very early metrics of bandwidth, throughput, latencies, and so on for very early iteration with the specification and for more tuning of the architecture of the interconnects. So we have solutions for this challenge, but it's always an up-to-date challenge actually, and it is always a present challenge. We do want to have the same test bench dedicated for these three levels of verification. And we want an automated test bench directly generated from the specification of the interconnect for time to market reasons and for early iteration with the architecture and with the specification. So this is always an up-to-date challenge. We have to be sure that actually the rope is never cut between these two guys. Let's move to the next one. Let's talk about this puzzle verification guy. Actually, the marketing guy's dream is to have the most generic SoC dedicated to cover many market segments. But verification is it induces always challenges for verification. How can we fulfill the ambition the ambition of diversification of the genericity of SoC? Let's take one recurrent case: functional mixing of pads. Actually, with the full genericity that we aim at, we are facing a lot of use cases of pad mixing. And we want to cover this in many ways. Actually, we can use formal verification to be sure that connection between IPs and paths are not broken, and to be sure that muxin are indeed there. But this is not enough. Actually, functional verification is quite important. We have to be sure that the implementation and the specification of the muxin of paths is correct. So this is creating a lot of use cases, and this is always a challenge of verification, of SOC verification. So this is why this guy is rocking his head actually, and he's always with this verification guy. So genericity and coverage is one of the most important challenges we have in SOC verification, and it will continue. Let's move to the next one. Actually, I like this problem. The early bird took the wall. In French, we would say, le monde appartient à ceux qui se lèvent tôt. And verification actually should do so. We should find bugs very early. It's fine to find bugs, but it's not enough. It is a necessary condition, not sufficient. We should find bugs on time. So I put here two kind of examples. The first one is RTL verification. How can we break the optimism of RTL in verification to be sure that we are seeing next bugs emerging in the next development phases? So there is a lot of examples of RTL verification optimism, like X-propagation, low power, CDC issues, and so on. So the idea, the request to EDA vendors is to give possibilities to break this optimism of RTL, to avoid seeing very late issues in final net lists. Another example of the anticipation that we want to put in verification is parallel development of SOCs in the same platform. This is very recurrent issues, this is very up-to-date issues actually. We do want to cross verification of parallel SOC to be sure that we are seeing problems coming in platforms and coming when we put SOCs together. So it's fine to make correct SOCs, but we should have SOCs working and talking together. This is why anticipation is very important in platform developments. So I have presented three challenges. There is many others, but these ones are the most recent, the most up to date actually. That's all.